Alright, today we talked about quadratic functions. You've graphed linear functions before. You did that to no end in 8th grade. And you used slope and y-intercept to get the job done. In 9th grade, you graphed exponential functions. So you had an initial value and a multiplier. And now we introduce the quadratic function. Yay! So slope-intercept form, just as a reminder, was y equals mx plus b, where m was slope, b was y-intercept, and your lines were always linear or straight. Exponential functions looked like y equals a times b to the x power, where y was your total value or ending value, a was your initial or beginning value, b was your multiplier, and x was your time period. And now quadratic functions look like y equals ax squared plus bx plus c, where a is the coefficient on the term called the quadratic term. A can't be 0 in a quadratic function, by the way. We've got to watch out for that. B is the coefficient on the linear term, and C is called the constant term. Quadratic functions, when you graph them, look like a big U. Some open up. We say open up because the open part is facing up. And some open down. This graph shape, this U, is called a parabola. It has tons of features, and we're going to hit on a few of them today. First of all, a 0 is where the graph crosses the x-axis. You've always called it an x-intercept, and it still can be called an x-intercept, but more specifically, we're going to start to call them zeros. Starting now, we're going to write our intercepts as points instead of just single numbers. So instead of saying my x-intercepts are at -1 and 5, I'm going to say my zeros are at -1, 0 and 5, 0. A 0, by the way, can also be called a root. So zeros, x-intercepts, and roots are all the same thing. Next, we have something called an axis of symmetry. When you had a shape, long time ago, you drew a line of symmetry if the two sides were mirror images of one another. Well, an axis of symmetry is what it's called when we have a graph. It's simply a line that divides our parabola into two equal symmetrical halves. Here's our axis of symmetry for this parabola. We need to know how to write the equation for our vertical lines. You have learned this before, but let me just go back and remind you a little bit about how it works. First of all, look at this point right here. What's its coordinate? That point's at 1, 2. This point down here is at 1, 0. If I pick another point on that line, it's at 1, -2, and another point is at 1, -4. What do all of these points have in common? What do they all share? The fact that their x value is 1. So when I want to show that all my x values are the same and all my x values are 1, I simply write x equals 1. And that's the equation of a vertical line. If I had a line over here that was vertical, it would be x equals -3. If I had a line over here that was vertical, it would be x equals 6. The vertex of a parabola, new vocabulary word, is the point where the axis of symmetry and the parabola meet. So I'm going to put in my axis of symmetry, and the point where the two meet is called my vertex. A vertex is either going to be called a maximum or a minimum, depending on whether it's the top of your parabola or the bottom. When I have a parabola like this one that opens down, my vertex is going to be at the top, and that's going to be called a maximum. If my parabola opened up and faced the other way, my vertex would be the lowest point on that parabola, and that would be called a minimum. So vertex is that point where the axis of symmetry and the parabola meet. It's always going to be the highest or lowest point of your parabola, and therefore called your maximum or minimum. Finally, a y-intercept of a parabola is the point where the graph crosses the y-axis. You've dealt a lot with y-intercepts before, so that shouldn't be a surprise. The only new thing is that we're going to write our y-intercepts as points now. So instead of saying my y-intercept is at 2, I'm going to say my y-intercept is at 0, 2. Our parabolas, remember the form y equals ax squared plus bx plus c. It's a really quick visual inspection to be able to tell whether your parabola is going to be open up or open down. And to do that, I'm really just going to look at A. If A is positive, your parabola is going to open up and have a minimum. If A is negative, it's going to open down and have a maximum. So in my first example, my A is 3. That's a positive number, so my parabola opens up and it's going to have a vertex that's a minimum. In my second example, A is negative 2, which means my parabola is going to open down and it's going to have a vertex that's a maximum. Next, we're going to need to be able to write the equation for the axis of symmetry. Now, this is a really quick formula. It won't take you very long to find this. And the formula for finding the axis of symmetry is x equals opposite of b over 2 times a. I'm going to call this opposite of b because this number will not always be negative. Opposite means change the sign of b. So here I have my example of 3x squared minus 6x minus 1. A is the number in front of x squared, that's 3. B is the number in front of x, that's negative 6. So when I put it into my formula, opposite of b tells me to take the opposite of negative 6. Opposite of negative 6 is positive 6. In the denominator, 2 times a now becomes 2 times 3, which also gives me 6. When I simplify, 6 over 6 is 1. So my axis of symmetry is going to be at x equals 1. Now that I know my axis of symmetry is at x equals 1, keep in mind that my vertex on the parabola is where the axis of symmetry and the parabola meet. So my vertex actually has to be on the axis of symmetry. Since my axis of symmetry tells me that all my x values there are 1, I already know that the x value of my vertex is 1. What I'm missing is the y value. And remember our functions when we had to plug in an x value to find y? Well, that means that we're going to find the function when x is 1. Basically, that means I'm going to plug 1 in everywhere I have an x. So here I have 3 times 1 squared minus 6 times 1 minus 1. 1 squared is 1. So I'm just simplifying here. 3 times 1 is going to give me 3. negative 6 times 1 gives me negative 6, and negative 1 gets brought down. 3 minus 6 minus 1 is negative 4. That's going to be the y value of my vertex. So since my x value was 1, my y value now is negative 4, my vertex is going to be at 1, negative 4. To find a y-intercept, remember that on the y-axis, I have lots of points, of course. Let's look at some of the coordinates of those points. For instance, if I had a point up here, that would be the point 0, 2. Sorry for my crude graph. Down here, this point would be 0, negative 1. And I could go on and on and on, but remember on the y-axis, what they have in common is that their x values are 0. So if I wanted to write the equation of the y-axis, it would be x equals 0. That's what all the points have in common. Sorry about my little update there. So I'm going to stick with my example of 3x squared minus 6x minus 1. If I want to find the y-intercept, I have to be on the y-axis, and that's where all x values are 0. So to find the y-intercept, I'm going to do the same thing that I did before, only now I'm going to find f of 0. In other words, I'm going to plug 0 in everywhere I had an x before. So now I get 3 times 0 squared minus 6 times 0 minus 1. 0 squared is 0. So 3 times 0 gives me 0. Negative 6 times 0 gives me 0. And the negative 1 just gets brought down. That's going to make y equal to negative 1. Since my x value is 0, my y value is negative 1, so my y-intercept is going to be at 0, negative 1. I want you to keep in mind through this whole thing that videos can be rewound. So if you need to go back and look up part of this video again, just do it. It'll be awesome. Here's the information that we have so far. We know that our parabola is positive, so it's going to be an open up shape. We know that our axis of symmetry is at x equals 1, which is the light blue line. We have a minimum, or our vertex, at 1, negative 4, and a y-intercept at 0, negative 1. Really, that only looks like it gave me a pretty bare minimum of information. But keep in mind that our axis of symmetry is our mirror for a reflection. So my y-intercept can be reflected across the axis of symmetry, and now I have 3 points. 3 points will give me quite a bit of my parabola, but it doesn't give me enough. I don't know how wide this parabola is going to go. I don't know how wide or thin it's going to be. So I need one more point. I'm going to find a point along this line where x is equal to 3. I could have picked any point or any x value except the 3 I've already used, 0, 1, and 2. If I go too far away, the parabola is going to be up off my graph and it's not going to do me any good. So I'm going to evaluate my equation when x is 3. So if I pick 3 for x, I'm going to plug that into my equation. Three squared is 9, so really I have 3 times 9 minus 6 times 3 minus 1. 3 times 9 is 27. Negative 6 times 3 is negative 18. And minus 1. 27 minus 18 is 9. Take away one more, I get 8. That means that part of my parabola goes through the point 3, 8. I could do that with more values of x at whatever value of x you want to choose, but I think 1 point's going to be enough. So now I'm going to come over to 3 and 1, 2, 3, 4, 5, 6, 7, 8. Did I count that right? And here's the point I found. Remember, because of my axis of symmetry, I can mirror that point to the other side. And now, super excuse my bad drawing skills, but now I know my parabola is going to look something like this. Remember, we found axis of symmetry. We used that x value to find our vertex, and then we used an x value of 0 to find our y-intercept. I found one more point on my graph just plugging a random number into my equation so that I could have a better overview of what my parabola was going to look like. Let me know if you have any questions. I'll see you next time in class. Have a great day.